Alright, I thought it might be useful to show you more explicitly how the equations in how some of the shallow water equations turn into code. So this right here is the equation that updates the water height in cell x and y from time t to time t plus delta t. So this will give us a new height. So the new height is just equal to the old height plus the amount of time that's passed times how fast the height of the fluid is changing. It's an equation that you'll see a lot of in these kinds of simulations. So in what follows in the code I'm about to show you, I'm calling this block of the equation right here the horizontal differences. So this is the horizontal change in fluid height, and then this other box right here, I'm calling that the vertical differences. So when I turn this into code, you'll see I break it into three pieces. Piece number one is the horizontal differences, piece number two is the vertical differences, and then piece number three is actually doing the update. So piece number three will be right about there. Alright, so now I've switched over to the code, and you can see piece number one, which is the horizontal differences, corresponds pretty closely to the equation itself. So I have u at position x plus 1 comma y, u at position x plus 1 comma y, and then I have times h plus hx1 plus 1 comma y, and that's this term right here, minus u at x minus 1 comma y, and then u at x minus 1 comma y. And then the final thing to notice is that I divide by 2 at the very end, and that accounts for 2 times delta x. So I'm measuring delta x as the number of grid cells over which I did the finite difference, and so 2 is the number of grid cells that I spanned, x minus 1 to x plus 1, so I divide by 2. Then in the next line of code I do the vertical differences, which is the same idea except I'm using v and moving in the y direction, also divide by 2. And then finally this is the code where I do my adaptive time step, well, at least keep track of the maximum change in height I saw. Adaptive time step, I've got it at 0.05 right now, typically I have it at 0.09, and then right here is where I update the value of h. And coming back up to my code, this is where I update the value of h. It's the old value plus delta t times the change in values. So it's the old value plus delta n times the change in values. And coming back up here, the total change in height is the horizontal difference minus the vertical difference. Unfortunately, I used a capital H here instead of a lowercase h. That's just in my variable naming convention. The change in what I'm calling delta capital H is actually the change in lowercase h. A little unfortunate. And the other thing that's a little unfortunate is that I'm using n to track time, and in the notes I use t. So hopefully that won't throw you off either. Okay, that's how one equation turns into code, and the rest are very similar. Good luck.